In this experiment being performed today, we will be observing how fractional distillation can be used to separate substances that are bonded by different intermolecular forces. As you have probably already learned, intramolecular forces are the forces within a molecule that keep it together. Intermolecular forces are the bonds between separate molecules, and therefore are the bonds that must be broken in order for a substance to vaporize. There are four major types of intermolecular forces: hydrogen bonds, ion-dipole bonds, dipole-dipole bonds, and London dispersion forces. Hydrogen bonds are very strong intermolecular forces that occur between a hydrogen atom and an electronegative atom such as fluorine, oxygen, or nitrogen. Ion-dipole bonds either occur between a positively charged dipole of one molecule and an anion, or a negatively charged dipole of one molecule and a cation. Dipole-dipole bonds occur between the positively charged dipole of one molecule and the negatively charged dipole of another. And lastly, London dispersion forces are the very weak forces that result from a temporary uneven distribution of electrons throughout a molecule. This fractional distillation experiment focuses specifically on the different types of intermolecular forces between water and ethanol molecules. Water experiences hydrogen bonding between its molecules. Hydrogen bonding is so strong that it is the cause of water's high surface tension and also the meniscus that you see when measuring volumes of water. Ethanol experiences both hydrogen bonding and dipole-dipole bonding. Compared to hydrogen bonds, dipole-dipole bonds are much weaker. These dipole-dipole bonds are depicted by the dotted line. And even though both water and ethanol experience hydrogen bonding, ethanol molecules are much more massive than water molecules. This weight difference makes the hydrogen bonds, depicted by the solid line, between the ethanol molecules much weaker than the hydrogen bonds between the water molecules. As you will see from the footage of our experiment, the differences in intermolecular bonding causes ethanol to boil at a much lower temperature than water. Now let's take a look at our experiment.
Fractional distillation is a method of separation using boiling points. The substance that has the lower boiling point will be able to boil off and be collected, separate from the substance with the higher boiling point. Today we'll be using a mixture of water with a boiling point of 100 degrees Celsius and ethanol, which has a boiling point of about 78 degrees Celsius. Now the fractional distillation apparatus is composed of several parts: the variac, heating mantle, round bottom flask, distillation column, still head and thermometer, condenser, bent vacuum adapter, and 10 milliliter graduated cylinder. The first piece is the variac, which basically acts as a power source for the heating mantle, which is the source of heat. The mixture of your liquids, in this case a mixture of 20 milliliters of ethanol to 30 milliliters of water, is going to be placed in a round bottom flask, and this is where all of the boiling takes place. We've added some boiling chips to speed up the process. Once one of the liquids begins to vaporize, it's going to move up through the distillation column, which is essentially a long glass tube with a bunch of pegs inside. The vapor will actually condense one time within this tube before evaporating again and moving through the rest of the system, so the pegs collect the excess vapor and make sure that all of the liquid ends up back in the round bottom flask. The next piece is the still head, and it basically acts as a connecting piece and holds your thermometer in place. Now the thermometer is really important to pay attention to. If you know the boiling points of your liquids, this can be a good indicator of what is boiling off. In theory, once the mixture starts boiling, the temperature should remain constant at the boiling point of your liquid with the lowest boiling point. Once you see a large jump in your temperature, you need to turn off the heating apparatus because you've started vaporizing your liquid with the higher boiling point. In the case of water and ethanol, you see a large jump from about 78 degrees Celsius to 100 degrees Celsius, but some liquids have closer boiling points, so it's incredibly important to pay attention to your temperature. Once your liquid has vaporized and moved through the distillation column, it's going to pass through the condenser. The condenser is a long glass tube insulated by another glass tube. The reason for this is that cool water will be passing through the two walls of glass, while your vapor moves through the middle. This will cause the vaporized liquid to recondense so that it can be collected in your graduated cylinder. The final two pieces are the bent vacuum adapter and a 10 milliliter graduated cylinder. The vacuum adapter is really just another connecting piece, and the 10 milliliter graduated cylinder is there to collect the separated liquid. For this experiment, we only collected up to 20 milliliters of liquid because we were aware of our initial concentration of ethanol. However, fractional distillation can be used to determine the concentration of an unknown mixture. Just to double check and make sure that our experiment worked, we performed two tests. We first smelled for ethanol by wafting the scent towards us, and it became immediately evident that ethanol was the liquid present. Our second test was adding water to the beaker containing our liquid. This resulted in wisps appearing as the two liquids mixed, which is indicative of an alcohol being present.